So once again, a very good evening, everyone. Probably this will be the last session among the all the 13 session of 6 days online FDP on remote sensing and GIS. So we have with us our esteemed guest, Dr. Nawnit Kumar. Dr. Nawnit Kumar is the director of Matshui Engineering Services Private Limited, a leading firm in India specializing in the design and implementation of wet utility system. He is a PhD graduate from Tsinghua University, Beijing, China. Dr. Kumar brings over a decade of experience in infrastructure projects, having successfully designed and implemented more than 70 projects across India. With a strong focus on sustainability and climate resilience, Dr. Kumar has represented India on global platforms such as the Shanghai Cooperation Organization, International Water Resources Association, International Water Association, and the International Commission on Large Dam. Under the leadership of Matsui Engineering Services, offers expertise in climate impact assessment to support sustainable development and is actively seeking collaboration to address the pressing challenges of the climate crisis. It's a privilege and honor to have Dr. Navneet sir as a speaker of the session. So, without wasting the time, I will hand over this session to Dr. Navneet Kumar sir.
Hello, good evening, everyone. I'll be
Good
starting
evening,
my
sir.
presentation.
Sir,
Uh, yes,
yeah, I'll just do one thing. I'll mute all and just allow you. So, now you can unmute yourself. Yes, sir.
okay. Am I audible and everyone can listen, see my screen?
Yes, sir. Yes.
Okay, great. Yes, so today I'll be talking about GIS for climate resilience infrastructure planning. So, what is climate resilience infrastructure? Infrastructure designed to withstand like climate change. What are the effects of climate change? Like there will be like flood, storm, heat waves, and like rising sea level. These are the impact of climate change. So we have to tackle this by building like resilient infrastructure by incorporating changes in our already designed infrastructure or like proposed infrastructure. So why it is important? Climate change is increasing and frequent and intensity of extreme weather events is increasing. And because of that, like the already designed infrastructure are like not able to cope up with the climate change. So it is important for us to take care of the climate change. Like we have to have various alternative scenario to tackle alternative climate event. So why it is happening? It is mainly happening because of urbanization. The amount of CO2 is increasing in the atmosphere. Because of that, the heat is increasing, the temperature is rising, and because of that, various activities like uh, melting of glaciers, snow cap melting, and all these things are happening. Because of that, sea level is rising, and because of the temperature variation, the wind movement has changed, and due to that, like various climatic events are happening. So what is hazard? Hazard is anything natural occurring phenomena that may have negative impact on humans. It is not always necessary that a hazard is a disaster, but when a hazard is having a negative effect, then it is called a disaster. So because of that, what should we do to see that like there is like not so much impact of the climate change? So here comes the climate mitigation. So in case of climate mitigation, we have to reduce the source or enhance the sink of greenhouse gases. At the same time, we have to see that okay, we are using low emission technology and renewable energies and changing the management practices and consumer behavior. So in this scenario, we can see like first like reduction of source or enhancement of sink of greenhouse gases. So once we plant like lot of trees, then it is a good sink of greenhouse gases. There is also like we can extract the CO2 from the atmosphere and we can pump it inside the earth. That is also one of the sink for greenhouse gases. And we can go and we can use renewable energies which are very low, which are having very low emissions. So first is climate mitigation, and the second part is climate adaptation. We know that anyway, like the global temperature is rising every year, every decade, it is rising. So we have to like this is a phenomena that will keep on happening. Like because of the industrialization, it has increased a little bit. In general, it is a natural phenomena which will keep happening. Like the more greenhouse gases will get trapped in the atmosphere, and the Earth temperature will rise. So we also have to see like how we are adapting to all these changes. So for that, we need to make some infrastructure changes, and those are that comes under climate adaptation. So then another part of climate adaptation is disaster risk reduction. So what we can do such that like the disaster, whatever, like because of the hazard, like whatever disaster that may come, we are reducing its impact. So here we will talk about vulnerability. What is vulnerability and how it is related? Vulnerability is defined as the propensity of predisposition to be adversely affected. Vulnerability encompasses a variety of concept and element like sensitivity, susceptibility. So in this, like it may be possible for a particular hazard, there is a part of community that is less vulnerable and a part of community that is more vulnerable. It all depend upon the sensitivity, degree to which a system is affected or degree to which a community is affected. And another part is adaptive capability. Like, okay, some people will adapt to the climate change and some people may not. So that adaptability is also comes under vulnerability. So all these things, hazard, vulnerability, exposure, they are all defined like, okay, what kind of risk and what kind of impact will be there because of the climate change. So now when we have talked about climate change, so in case of infrastructure, these are the general climate risks like pluvial and fluvial flooding, coastal flooding, damage to infrastructure, energy disruption due to flooding, marine transport, land-based transport. Like these are major things that impact the infrastructure. So today we'll be focusing mainly on like flooding, coastal flooding, storm water, and other things. So, sorry. We have already talked about adaptation and mitigation. So using both, we can use like, okay, this can be used as a climate resilience. Like when we have to become climate resilience, we have to focus on both adaptation and mitigation and come to a balance to become a climate resilient society. As we have already talked, because of CO2 emission, there is climate change. And the climate change, it will impact because of this, there will be increase in temperature, increase in precipitation. When there is increase in temperature, there will be drought, snow melts. When there is increase in precipitation, there will be extreme flooding. And if these events become very extreme, then it will affect health and livelihood of the people. It will also affect the infrastructure. So, sorry. Whatever we do to reduce this will be our mitigation step. So this whole thing, like, okay, this comes under mitigation. Like based on this climatic changes, we have to do climate adaptation. And whatever the adaptation cost should be based on life cycle analysis. So what we need to do first we need to identify the problem and prioritize the sector that need to be climate resilient. And based on that, we have to come up with the adaptation scheme. and we have whatever adaptation that we are gonna take, it should be environmental and socio-economical valuation of the risk reduction should be done, and based on that a decision need to be made. So I'll be skipping this and moving to the next topic. When I was talking about optimal adaptation strategy, mean in this either like you can see, like we can invest more in climate adaptation, so the risk will reduce. You can see the orange line, it shows like okay, damage is reduced, but at the same time the cost will become too high. So we have to come at an optimal point where we are doing climate adaptation and mitigation at the same time. So what are the characteristics of resilient infrastructure? First is to minimize the impact of climate change and utilize climate information to reduce the vulnerability, empower the community, and also to take adaptive measures. All this make a resilient infrastructure or a resilience municipality. So when we are talking about climate proofing, we have to see like, okay, what are the challenges there? And based on that, what will be this and what will be the cost? We have already talked about this in the previous slides. So we have talked about all this, like, okay, because of the climate, there will be some changes. So how to assess that and how GIS can be helpful in that? We all means till now you already have known what is GIS and how it is used. So how it can be used? It can be used for risk assessment, resource management, infrastructure design, and disaster response. So today we'll talk about like one case study of flood risk mapping. So 1 minute. This can be GIS can be used for flood risk mapping, urban heat island mitigation, coastal resilience, and all that. So our case study here will talk about urban flooding. What are urban flood? Because of climate change, urbanization, and urban development pattern, and due to underdeveloped drainage system or drainage infrastructure, there is urban flooding happening. So you must have known till now, you know that okay, what is a hydrograph? Hydrograph is a curve between runoff and time. So for a post pre-development hydrograph, the peak will be low and the time in which the runoff is happening is more. When there is urbanization, the time of concentration, a time of runoff is less and the peak of runoff is high. So because the peak is high, the existing infrastructure may not be able to cope up with that peak discharge, and this may cause the urban flooding. So what can be done to reduce or mitigate the urban flooding? What we can do, we can use like we can have like flood control infrastructure, storm drainage system, retention and detention basin, green infrastructure, flooding zone, emergency response, and a flood warning system. So in this, like, okay, there is one of the major component that LIDs, we used LIDs as of now to increase the capacity of the drainage system. Or like if you see from LID is like a small concept, like in a bigger like city-wise concept, it is called like a spawn city. And the concept is to retain 70 to 90% of annual runoff. So this way we can reduce the urban flooding. This is a particular case study of Patna. Means this is a Bakarganj area in which there are like one green area and one like urbanized area which has very less of green area. So in this we have seen that it has like a total like network of 11.4 kilometer and a catchment of 2.56 kilometer. Very small catchment for a case study. So in this, we saw like for a particular rainfall, the runoff from urban area was very high, while the runoff from this green area, combined green area and urban area was relatively less. So before doing this case study, what are the data that we require? We required topographical data. This map is made in GIS. It was made based on use of topographical data that was collected on site, and at the same time this can also be made with the help of some satellite data like SRTM data are there that can be used to make a topographical map. Similarly, this is the drainage network and drainage network of the area, and this one is the land use and land cover map of that particular area. In addition to that, we have also considered like okay major rainfall and runoff for that area for doing the calibration of the model. So here you can see this is how we use like all this data, like they were generated in the GIS, and with the ultimately we'll be using all this data to combine and to find the best suitable location for the LIDs to be placed such that it can reduce the urban runoff. Here, this is the 10-year moving rainfall intensity for Patna. So for moving rainfall intensity, like here, like last 30 years, the average rainfall intensity was 5.5. But as you go up, the average rainfall intensity is increasing. So this is the effect of climate change. Like every year, the average intensity of rainfall is increasing. So if a particular infrastructure was designed for this 5.5 intensity, it cannot cope with like this intensity of rainfall. So in this particular case, we have taken like rainfall data, 15-minute interval rainfall data from IMD Pune. And we have also daily rainfall data from a global climatic model, which we did the down scaling bias correction and down scaling. And we like made an IDF from this. We made an IDF for that particular area for different climatic projection. We used like SSP like 2.5 and SSP 2 4.5 scenario and 8.5 scenario. These three scenarios we have used and done the climatic projection for that. And for those we had made the uh, IDF graphs. And based on those IDF graphs, we put those IDF graphs in our software, and we saw like okay which area which is having what kind of runoff. So as of now, because like you have already like gone through like a lot of these kind of lectures, you may be knowing like there as per IPCC annual AR6, there are different scenarios for climatic projection. So some is optimistic, some is pessimistic. So we have to see which is the current trend, and based on that, we have to project our climatic projection. So because of climate change, there is rise in temperature, increase evaporation and drying, precipitation intensity is increasing. We have already talked about all these things. So as I was talking about, like for different scenarios, we had created IDF. So major finding was that 10-year moving rainfall intensity increased by 1.75 mm in last 30 years. And there was 13.71% increase in rainfall intensity. And it was also means okay we did like a different kind of scenario, and like there was for SSP 8.5 obviously the condition was really worse, and there was like flooding in different areas. Like these red nodes, it shows that okay these nodes were flooded. So in this we have used two softwares, like one was GIS and another was SWMM we have used to uh, to find like okay the flooding area. In this also, like for making all this catchment, we had used the GIS. So once we have decided like, and in that like later like we did different scenarios, one with LID, one with LID with SSP 8.5, one without LID. Different kind of scenarios was there, and for different like we saw what is the runoff peak. So now once we saw that like okay LIDs were using better, then like we also did like okay what will be the optimal location for different kind of LIDs. So in that we did multi-criteria decision analysis for different kind of LIDs, and we came up with the ranking. And we used all this ranking to create a site suitability map in which like this land use map has like different suitability. Then there was flooding area permeability. So we made like GIS map of everything: land use, flooding, permeability, proximity to road, drainage, slope, soil characteristic. For all these, we had made the GIS map, and we combined all those. We combined all those maps to identify which will be the best suitable location. This is a site analysis as per land cover. So this was the vector data we converted into raster data, and it was like classified between like 1 to 5. Similarly, topographical data was also means classified based on slopes, and it was given like band from 1 to 5, ranking from 1 to 5. Different slope has like different benefits, and proximity to road, and also like different weightage were given to like different kind of like the one that was near the road like that can be used that will be the best suitable location for LID. So they were giving the highest ranking, and the one that were further from the road, they were giving the least ranking. So this way, like we created different kind of raster maps, and this was for our soil characteristic and perviousness of that area. Same 1 to 5, 5 like okay, 5 we were giving for buildings because they can be used as a green roofs. So here you can change like okay based on what is your objective, you can change which has like a higher priority or a lower priority. You can give like criteria weight. And also like what we had done in the initial that the places which were prone to urban flooding, those were given high rankings that okay these are the priority area which need to we need to do something to mitigate the impact of the flooding. So based on that, we made a prioritization map for LID BMP structures, and for that we did a site suitability weight distribution, and we saw like this area the from that we decided like okay which area should be best for LID. So the one near the road, like one that were above like 3.4, they were like more suitable for the LIDs. So this is how you can use like GIS with the help of other softwares to analyze like okay which to make a system like a stormwater system least vulnerable or like adapt to the climate changes. So here like our initial the thing was there was a existing drainage system which was designed like approximately 50 years back, and because of the climatic scenario and like lot of rainfall changes and also other issues there were flooding. So we had to analyze like okay what need to be done so that okay we can reduce the flooding. So for that like we chose an adaptation measure that was LID BMP, like low impact development structures. So we need to know which area, which place will be the best for those kind of LIDs. So for that, okay, we took different cases and we came up different factors that affect the location of these structures, and based on that, we prioritize that okay, the one which is greater than 4.6 or 4, they are the most suitable places for placing the LIDs. So after this, like when we do any these kind of analysis, we have to also do the sensitivity analysis. We have to change like okay different parameters and see like okay because like we were using weight. The weight were like manual input, and it was also based on survey, like user stakeholder survey, user survey were done to come up with those weightage. So there may be changes. Like if you take a small group, the weightage will be different, and but if you take a very large group, the weightage may change slightly. So we did a sensitivity analysis, and we checked for different scenarios. We had made like reducing flood probability, increasing topography weightage, decreasing permeability. So we made all these scenarios, and for that we saw like from all these four, which will be the best suitable, like even with the sensitivity, which is best suiting the location for LIDs. So we segregated the site suitability map based on 90 percentile weightage, and ultimately these were the location that were most optimal for the location of LIDs. And also we did another MCDA for different kind of LIDs, and we had given different rank for different kind of LIDs. So integrating site suitability map with flooding probability map, you can see like the place where flooding, like there our site suitability is better. And this shows like LID allocation based on spatial suitability and ranking as per MCDA. So here you can see different color, like these are mostly the roads, they are better for infiltration trench and soakways, while the inside area they are better suited for BRCs. And at the same time, when the inside road, those are like very small alley, they are better suitable for permeable pavements. So we chose these three LIDs, and we saw like okay which is better for that. So all this was done in the GIS using MCDA, and for that like we had already developed, means we had developed a QGIS plugin for the same. Like later we made a model. In that we did all the process manually, and later we developed LID plugin to in which like you can input all the layers like flooding nodes, perviousness, and like soil permeability. And based on that, it will, and you can also select the area, like okay, what is the area that you want to select. You give the weightage to a different kind of part, and based on that, it can give you the site suitability for placing of LIDs for a particular area. So this was one of the example of using LIDs, using GIS for making urban infrastructure to adapt to climate change, to making a climate resilience infrastructure. So in this, like because of that, what means it was a very cost-effective solution. It was based on data, and it is a sustainable solution because we are increasing like using LID. It means like okay, we are retaining most of the water, so we are increasing the ground infiltration. And also here like okay, we have taken input from the stakeholders and different people, so we have also used collaboration. So all these four aspects of GIS were used in that particular case study. So what were the challenges and limitation? Like okay, data quality based, I mean, if the data quality is not good, it will give inaccurate and outdated result. Like data can lead to poor decision. And also like there is a cost, like to getting all this data there is a considerable cost. And as of now, like you need a technical expertise to use any GIS tool. So now what we are doing, like okay, we are also integrating like when now everything in GIS is getting automated with the help of chat GPT. You can make your own plugin and all that. So we are also doing AI integration. At the same time, it can also be used for real-time monitoring. 3D modeling can also be incorporated in that. So these are the future trends that can be used in GIS to for making a urban infrastructure climate resilient. Thank you. If you have any question, you can ask me right now, or you can email me, or you can text me.
Any one of you? You can unmute yourself and you can ask any question.
Sir, this is Karthik. Which climate scenario is best for our Indian climate study?
Generally, I think RCP like SSP 4.5 scenario we take for Indian
Okay.
scenarios.
Okay, sir. For specifically temperature study, which scenario is best, sir?
Actually, we don't do temperature study much in my company. We like mainly do like stormwater related thing. So I'm
Okay,
not
sir.
much aware about the temperature one.
Okay, sir. Thank you. Thank you, sir.
Anyone? Any more question, please? Thank you, sir. Thank you for.
Thanks a lot.
Yeah, thank you, sir. I know. Yeah, there is one question, sir. Yes.
Okay.
Anyone? Thank you, sir, because you were having a meeting, and despite of having meeting and despite of being so busy, you took the time and you shared your views. So thank you once again on the behalf of organizing team. I am very thankful to you. Looking for some more sessions in coming future. So once again, sir, thank you. Thank you for being here, sir.
You're always welcome. It was really nice talking to all of you people. And if you have any question, any concern or anything, you can email me. This is my email ID. This is our company's email ID. If you send anything, I will get it in this email ID. Okay. Thank you.
Okay, sir. Good night. So, dear all, this was the last session. So, before proceeding towards the validatory session as well as the test link, I request some of the participants just to share their views and as the feedback of the entire 6 days FTP. So you can share your feedback. You can just switch on your camera and you can unmute yourself and please try to share your feedback so that in future also if we want to organize this kind of training session we can improve ourselves. Please, sir. Any one of you voluntarily want to share the feedback? I request you to please share the feedback.
Hello, sir. This is Rishikesh Anand.
Yes, sir.
Yes, sir. For me, GIS is like I know little bit about GIS, but in these 6 days, I have learned a lot about GIS and its technology and its technicalities, how to use it. So this will be very grateful and helpful for my upcoming journey. Thank you so much, sir.
Anyone more? Anyone? I request 2 to 3 more participants just to share the feedback of the entire so that we can start with the validatory session.
Hello.
Yeah.
Thank you, sir. I would like to express my heartfelt appreciation to the organizing team for conducting such a very wonderful and informative, well-coordinated FDP programs. The 6-day FDP was really, really very planned and executed, and it will really helpful for us. And the selection of expert speaker was outstanding as they shared valuable insights and real-world applications. And the organization ensured seamless management of the program. It was really, really wonderful, sir. Overall, the FDP was resounding success, and it has great enhanced our understanding of the subject. Thank you so much, sir.
Any suggestions for our improvement?
Sir, actually today's especially for today, today is a 4 to 5 session. So because of working, we are not able to attend all the session. Especially today, I'm unable to listen all the speakers. So if one day 2 speakers is enough for us, but 4 to 5 speakers really we are unable to listen to all the speakers because of working.
Okay. I just want to clear one thing. Actually, this timetable is being set by AICT only. So we are bound to, do the sessions in that time only. So due to that reason, I have to do 3 sessions today. Anyways, I will just keep this thing, these things in mind.
Yes,
Anyone
but
else?
sir, the selection of speakers were really very wonderful, and all the speakers are really very good, and all the sessions are really very informative for us. Thank you so
Thank
much,
you.
sir.
Thank you.
Hello, sir.
Yeah.
I actually congratulate you for such a wonderful FDP. And I joined lot of FDP, but the selection of speakers and topics and case studies are so much helpful for us, na. I really thank you for this FDP, and I want to suggest one thing. Please share all the PPTs, and second, please organize one more FDP for hand-on training on GIS softwares.
Thank you, Aarti ma'am. And all the PPTs will be shared to you. Don't worry about that. I am collecting all the PPTs, and once it is all collected, I will share you. And yes, if possible, if AICT will approve our next FDP, we'll try for the hands-on session. So once again, thank you. And anyone
Thank you,
else?
sir. Thank you.
Yeah.
Sir, good evening. Thank you so much for conducting such a wonderful workshop. Actually, as Madam earlier said, that the selection of the speakers were really tremendous. Right? They were very awesome for their delivering the speeches. My suggestion is that, if possible, in future due course of time, kindly try to make this as a offline, so that we can have some on-hand training with the upcoming softwares with respect to GIS, and whatever which you have included in your what you call it as FDP. Those are relevant to our VTU, Vishwesvaraya Technical University, Karnataka, Belgavi. This was very reliable, and it was very helpful for me to guide my students in upcoming courses. Thank you and congratulations for the same, sir.
Thank you, sir. And I also want to tell you all that I will share the link here only, test link. You will be given almost 20 to 30 minutes. You have to, submit the answers. But before sharing the link, I will like to tell you one thing, that please do it very carefully, because the marks required for certification is minimum 70%. So there are 20 questions. You need to score at least 14 marks and at least 80% of attendance. And one more thing, the feedback link. Whenever you will log into your Atal FDP through your participant link, there you will, when you will select our FDP, there you will get the feedback link. So you have to fill that form also. Uh, until and unless you have not filled that form, your certificate will not be generated. And the certificate will be available from Tuesday, because once you will give the test, we'll assess that test and we'll feed your marks. And on the basis of feeding your marks and attendance, you can, after submitting the feedback link, you will be eligible for the certificate. Any queries regarding this?
The link is available in Atal FDP portal or here?
Which link, sir?
Examination link.
No, I'll share here, because there the link is not activated. So I'll share here. So before activating the link, I will request the coordinator of the FDP, Mr. Vijay Srivastav, sir, for a thank you note, so that we can start with the test process.
Thank you, Ankur. Am I audible?
Yes, sir.
Yes, sir.
Thank you. Good evening, everyone. As a coordinator of this FDP, it's my privilege to extend a heartful vote of thanks at the conclusion of this FDP. First and foremost, I express my sincere gratitude to all the speakers for sharing their valuable insights and inspiring us with their knowledge and expertise. I also extend my appreciation to our director, sir, and the management for their continuous support and encouragement to organizing such a wonderful FDP. I also extend my gratitude to co-coordinator Mr. Ankur for their tireless effort in the planning and execution of this program. Last but not the least, a heartfelt thank to all the participants for their active engagement and willingness to learn. Once again, thank you to all of you for your valuable time and contribution. Thank you, Ankur.
Thank you, sir. So once again, thank you, everyone. I know that time was a little bit, it was out of the box because we all are working. So you have to take out time from your daily course and then you have to join the session. But every day I can see near about 150 participants were there. So thank you for your dedication. It means it was a successful event. So here I am uh, sharing the link of the test. So you all can now assess the test. Here it is the link. So you all can assess the test and please
Ankur,
do.
Ankur, you can increase the time of to 30 minutes or 20?
Yeah. It is up to 30 minutes. The 30 minutes.
Exactly.
Link is here. You all can now assess the test. Do remember one thing, you need to qualify you for the certificate until unless you are not scoring less than more than 70%. So please try to do it very carefully. There are very simple questions. Yeah, they are very basic questions from the sessions only. So please do it very carefully. Rest, you all, I assure you all, from Tuesday onwards, you will be able to download the certificates. Once the certificates are available, I will let you know in the WhatsApp group.
Right. Thank you, Ankur sir. Thank you a lot for your dedication and time also.
Thank you, sir. Thank you. It's our pleasure.